Welcome back, everybody. Um, Today we're going to pick back up with the match function, and then we're going to get into a bunch of pretty simple functions, math functions. So, match is one of these functions that is included on the string prototype of or the string prototype built into JavaScript. Um, we're just going to start with the type signature. So it takes two arguments. The first is a regular expression. The second is a string. So the string to be checked by the regex. And it returns an array. And the array either contains strings or undefined, right? And let's see if there's anything in here. Yeah, so the first argument is a regex. The second one's a string to match against. And it returns an array, the list of matches, or an empty array. So that's a key right here that's different is empty array. We look at it, it says it tests a regular expression against a string, just like the match method does on the string method built into JavaScript. But note that this function will return an empty array when there are no matches. This differs from the string.prototype.match, which returns null when there are no matches. So this gives you back an empty array instead of a null. So you don't have to check if something's null first. Of course, you got to check if the array is empty, maybe, but that's what they decided to do. So that's pretty cool. Um, I have to admit that regular expressions are my kryptonite. I very rarely use them. I mean, I really never use them. And if I do, I'm like Googling, how do I make a regex to blah blah blah. Honestly, I find that anything you need to do with a regex, you can do with an array and array functions and methods and stuff, depending if you're using Ramda or just native JavaScript, built-in JavaScript. Um, because strings are basically arrays of characters. You can always split a string into an array and then just do that. But here we're going to use this. So I'm going to grab it. I'm going to grab this example. So this regular expression is easy enough. The parentheses mean there's a capture group, and the G means global. So it's going to look for anything that matches this in this string, but not just the first thing that matches, but all the things that match. And then it's going to give us an array of all those things. So an array of zero or more things. So what it's going to look for is any lowercase letter A to Z followed by a lowercase a. So in this example, B is followed by an A, so that would match, and we would get BA. But A is not followed by an A, so it would skip that. N is followed by an A, so we get that, but not the next one. A is followed by N, so that doesn't count. And then just like the previous one, N followed by an A counts, so that we get that one, but A is not followed by an A, and so that one is skipped. So I think that's three that we get. So let's just run that and see what we get. Hmm, strange. Maybe I didn't save it. Oh, yeah, I didn't save it. Okay. Wow. I thought I started thinking like that last video, like maybe they added this after I installed the npm package for Ramda. Anyway, we get BA, NA, and NA, just like I described. So here there's a thing that's saying if you check for an irregular expression in null, you get a type error. Null does not have a method name match. But that makes sense because it's telling you you have to pass a string, and null is not a string. And then if we just check like the string of O, we're going to get back an empty array. But if we did um, the string O, that's a zero, the string O dot, I think it takes one argument. This is like the native JavaScript, but that's wrong. Oh, maybe another set of parentheses because that's a capture group. Or no, no, it's not. Uh, Gosh, I don't know. Okay, let's comment that out. I don't know how to use the. Oh, dir. Again, didn't even write the name of the function or the method. Dir method. Match. Yeah, maybe that'll work. Yeah. So we get null instead of empty parentheses. So when you're using the native match method, you'll get null back if there's nothing found. Otherwise, but with Ramda, you get an array. So that's basically that. I don't want to spend too much time lingering on it. But let's see also test, which is similar. This one just takes a regex and a string and it returns a boolean. So it's a predicate, right? It determines whether a given string matches a given regular expression. So this one's just going to say, yeah, it does, or no, it doesn't. It's not going to, if it finds it, and if it's true, it's not going to give you back the thing that it found. So I'll just run that real quick. Copy. Yeah, and so that's true. We did Z, Y, Z. We get false, right? So again, test is also on the string prototype. So these are just random versions for it. And really simple or really handy, I should say, if you want to partially apply these. Um, Test X maybe. Test X for this. We get true. I think that means maybe starts with. Yeah, that starts with. So that's false. So yeah, that's all there is to it. So that's our regular expression functions today. And now it's time to jump into a whole bunch of math functions. So let's just clean up a little bit and look at math mod, right? So we've got math mod and we've got modulo. And I've run into this issue with using the print, the percentage symbol character. Like if I wanted to say, if seven, I read this as seven modulo two, but I read this as like seven divided by two. What's the remainder? Um, and it is one, right? Because you could do uh, two times three is six, and that leaves one, and so one is the remainder. And for me, that's good enough, right? And like I've literally used this for only two things in my life. One is the check if a number is even or not, because you could just say this equals 0 and you get false. But if it was like an even number, you get true, right? I think we've all probably done that. Um, so this gives this sometimes when I've read this in documentation, it says the symbol is the modulo, but it's not. It not mathematically speaking. It is the remainder operator. Um, the other thing that you can do with this is if you have like a carousel of images on a website or something, and then you want to, click next, next, next. And then once you get to the end, you want it to loop back to the beginning, you can use the modulator to do that. I don't remember exactly how to do it to demonstrate it, and I don't want to look it up, but armed with that information, you could go find it if you wanted to. I believe in you. So, that said, let's read this. So we take two numbers and return a number, right? So math mod behaves like the modulo operator should mathematically. Unlike the percent operator and by extension r dot modulo, right, which we'll look at in a minute, the negative 17 modulo 5 is negative 2. Math mod negative 17 and 5 is 3. Math mod requires integer arguments and returns not a number when the modulus is 0 or negative, right? So in JavaScript, you can use negative numbers for the first number. We got negative 0 um, to something different. Yeah, so we get negative 2. But mathematically speaking, this violates that rule. You're not allowed to have negative values. Um, and yeah, you can't have anything less than 0. So honestly, I cannot understand why math mod negative 17 divided by 5, what's the modulo or whatever. It's not even divided by, strictly speaking. Um, I'm not a mathematician by trade. So you can go look up some more information why the difference between remainder and math.mod. Um, and there's another note when we look at modulo. I think honestly, modulo has always worked for what I needed to do. So I think it's rare that I'm going to use this. Maybe if you're doing some actual math intensive stuff, you might want to use this. Um, Most programming languages have the same thing where they use like the modulo type. When I say most, I mean like the ones that we use. Um, C Sharp, Java, PHP, but programming languages like R and even Python and Haskell, they're going to use the math mod version, like the math version, right? So that's the only thing that I think you want to be worried about here. You could looking at these examples, but I don't think we need to spend too much time on it because it's a pretty simple, thing if you're just trying to get the remainder. And I think that's what we're normally doing. So let's look at the modulo function too. It has the same type of signature. It takes two numbers and returns a number. It divides the first parameter by the second and returns the remainder. Like in my mind, that's what I need modulo for. Note that this function preserves the JavaScript style behavior for modulo. For mathematical modulo, see mathmod, which we just looked at. So I might not even use done an example of the math.mod, but let's do one for modulo. So in fact, let's make an ifs even function. All right, so that's going to be r dot modulo 2. But we need to divide by 2. This is the second argument. So let's do a flip a lot, but let's do the placeholder. All right, and will that let us partially apply with that? I think it will. Let's do is even 4 and is even 3. Yeah. Oh wait, no. Then we need to say is this equal to 0? So let's use a pipe. All right, so that's the first thing we'll do, and then we'll check if r dot equals 0. I like that. I feel like that's kind of clean and easy to read. Yeah. So 4 is even and 3 is not, right? So I think that's pretty cool. And what happens if we do like a -3 and a -4? True, false, false, false. Right. So yeah, because that's interesting. I thought that this would be true. So now I'm gonna say math mod. Let's see if we get anything different. Yeah, here, so we get true false for 4, 3, but then we get -4 is true. It is even, and -3 is false. So maybe I will start using math mod. Now I have decisions to make. I wish there was just one. I mean, if we've gotten along this far with just modulo in native JavaScript, maybe I can use that. I guess the main thing is just like run the calculation with a calculator and see if the function you're using is giving you the correct value. Otherwise, look at some math tutorials, on the subject and figure out what's what. But yeah, that's math mod. Um, I don't think we're going to have too much information here. The value to divide the pseudo modulus and the result of B modulo A. Um, and I always question is the word modulo or modulus and like when do you use which? I don't know. This is all for the math guys to figure out. One thing I will notice mention is that these type signatures are starting to bug me a little bit. I really like them versus the kind of type signature you get with TypeScript or when you actually like create a type or annotate code with types. Here it says number, number, number. Sometimes it would say A, and then have on a separate line, a type constraint that says number or A is a type number. But here they're saying number up here, but then they go to A and B down here. So you just have to know the first thing's A, the second thing's B. A little inconsistent. Um, but I still like it. I'm just mentioning it. I'm not meaning to complain about it. Um, yeah. So let's go back to Math Mod and then scroll down, and then we've got some really easy ones. So we've got max. This is a relational function. This is there's math.max built into JavaScript. So you can say math.max 1, 2, -4, 16, 5, and 4 again. Or not again, but 4. And then if we run that, it's going to give us 16. Just give us the biggest number. Now note this is a variadic function, and these arguments are not passed as an array. They're just individual arguments. So in Ramda, they prefer to stay away or avoid functions that take variadic arguments when possible. And the reason is because it makes it less straightforward to compose functions. Functions are easy to compose when they all take an argument, one argument, and only one argument. Uh, and as long as the types match up, you can just compose all day long. And if you start with two arguments in like a pipe, and all the rest of the functions in the pipe only take one argument, the first one takes like two and the rest take one, that's not so hard. But when you've got to switch and go from one argument to a function that takes two arguments and then back to a function that takes one, the level of difficulty grows quicker, like exponentially. And there's tricks. We've got functions we haven't looked at yet, like in-array and things that you can do to get around it, but it's easier if you don't. So that's why this returns to the larger of its two arguments. And then you say, like, well, wait, what if I want 16 arguments or 16 numbers? I want to check it. How do I do that? I don't want to nest mathmax inside mathmax inside mathmax. That would just be so hard to read. So the answer, um, well, I'll show you the answer in a second. I skipped the type signature. So this is what I was saying a second ago. Like these are all numbers, A, but here it's got this type class where it's saying that A is an orderable thing. So that's going to be numbers or strings generally. Maybe there's other stuff, but those are the two main ones. Um, so if we're using Ramda, max, and you know, 4 and 2, right? I mean, it's four. But if we had a list of things, what we could do is we could, let's say, x's equals 1, 3, -2, 3, 1, -1, and let's throw like 12 right here. So it's not the last one. So we've got this array of x's, and we want to check the other one. The easiest thing to do is use reduce. And we haven't used Ramda's reduce, but I'm assuming that if you're looking at Ramda, you're very familiar with map, filter, and reduce. Those are like the three array methods that you can do just about anything with. And honestly, you can make map and filter with just reduce. So really, reduce is like the one function for arrays that rule them all. And so you need a function, and we could just say r.max, right? And then we have the starting value, and then we pass in the x's. So the only question is, how do you start? What's the starting value if you're doing r.max? Like it's not zero because we have -2 and -1 in here, and zero is greater than -2 or -1. So we need a really low number. So if you just always start with a number that's lower than anyone in the list, then this will work. And so the way to do that is if you're using r.max, they say the identity of r.max is negative infinity. Infinity, yeah. So you know, any number other than negative infinity is going to be less than negative infinity. Or I'm sorry, it's going to be greater than negative infinity. So if you start that, you reduce, and it's just like you start with negative infinity and you check that against one. And of course, one is the max. So now one is the accumulator. And then you check one against three. Three is greater than one. So three is the accumulator. And then you check that against -2, and three is still greater. So it's still the accumulator, and so on. Um, but so now we're passing the arguments as a list instead of just individual arguments, no longer variadic. Um, and then it says, see also min, and it's the same thing, returns the smaller of the two arguments. So we could switch this to min, and then the identity of min is infinity. So it's the same thing, but you're starting with like the largest number possible. Every number is going to be smaller than an infinity, except another infinity, and those would be equal. So it's still going to work. If I save that and then I go back, -2 is the smallest number. So that's min. And we can look at letters. We could say A, B. Now, I think every one of us forgets like is A the first letter or is A the last letter? And then there's capital letters and lowercase letters or uppercase and lowercase. Um, so you just try it, figure it out, or if you've got a way to remember it, good on you. So let's just do our ABCs and see which one's the min. Interesting. We get, oh, you know what? Infinity is not going to be the, interesting. Yeah, infinity is not going to be the lower number because infinity is number and um, strings are not numbers. Strings are strings. Now I'm guessing, I think it is. I think the identity of men in terms of strings are is an empty string. That may be wrong. And when I say identity, I'm confused myself with like I know what the identity function is. You pass it an x, you get back the same x. But I think there's another conceptual meaning of identity. And this probably gets back into category theory or lambda calculus or some sort of math thing um, that I just don't grasp 100% yet. So let's just go with it. Let's see if I get lucky. So string is lower than that, but for max, it works. But if I wanted to do min, I mean, I could just say Z, right? Or Z, depending on where you live. I'm an American living in London, so my English is all mixed up. Um, and you get A, and that's what you want. And there's only, you know, there's an infinite amount of numbers, but not letters. So just start with the other one. And then I can't remember if like uppercase letters where they fall in line. So uppercase Z is the lower number compared to these. So I guess capitals go first and then lowercase or something. Yeah, I don't know. I don't think we're often looking for the minimum letter, in a word. But if we are, just go through it, write your test case, and then make sure your function passes that test. So that's math and max and min. Nothing there. And then you've got max by and min by. And so this is kind of cool. This isn't something I thought you would need, but it could be handy. Max by takes uh, uh, the B in this type signature is going to be an orderable, right? And so number or a string. And then the max by function is going to take three arguments. Going to take a function that goes from A to B. So B is, remember, an orderable, so string or number. And then it takes two A's, which I'm going to guess is the things we're comparing, and return an A. That gives us nothing. It takes a function and two values, right? So again, not variadic. And it returns whichever value produces the larger result. when passed to the provided function. So they have this interesting example here. We've got a square function, nothing crazy there. Takes an n and multiplies them together. And then we can do a r dot max by, and first argument is a function, so we'll pass in that square function. And the second argument here, so we have like a 3 and a 2, right? And we want to know and so what we do is we take the 3 and we square it. And that's going to give us 9. Then we take the 2 and we square it, and that's going to give us a 4. And then it's going to basically run the max function. It's going to say which of these two numbers are greater than, uh, since it's max, which is the maximum number. Um, so let's run that. And we get 3. So even though we take the 3 and square it and we get 9, that's not the result. That's just like a side calculation inside the function. So it's basically like which of these two numbers are greater or the maximum after we square them. Is it 3 or 2? But where this is useful, and like here in the example, is if you have a -3 and we run this, -3 is the max after you square it, because -3 times -3 is +9, and 2 times 2 is 4, +4. The 9 is still greater than 4 after it's been squared. Um, and otherwise, like if that's what you were going for, you could just calculate the absolute value of the number. But I mean, this is just squaring. So like maybe there's some other calculation that you would use. So this could be handy. I find it simple to use. You could partially apply this with like r dot max by square. What happens if we had multiple, because this is still taking two arguments, I think. Let's bring this back. Oh, see, this is an array. This isn't going to work. I want to prove it though. Yeah, that just gives us a function. Because it takes two arguments. But what if we wanted to know, like if this list thing would work? Could we do r dot reduce like we did on the other one, and then pass it that, and then pass it max by. Okay, so max by. So we would need to do -infinity, and then pass it these x's I have above. What would that do? It give us -infinity. That doesn't work either. Oh, but here, oh, this is the answer. Okay, I didn't know that was there. Let me copy this and let's look at it side by side. And we'll just pass the x's. Oh, okay. So I guess the problem is, that's confusing to me. The problem is I shouldn't have used -infinity. I should have used 0. And if we're squaring it, the result's always going to be positive. So that makes sense. So I guess you just have to think about it based on your data set and what makes sense to be the starting value, the value that's always going to be lower than the max or always going to be higher than the min. For example, if we go to min by, you know, get a mental snapshot of this, and then when I click on it, it's like the same thing. and type signature. We're just, checking the smaller one. And here, yeah, if you wanted to find out what was always smaller, you would use infinity instead of zero. Oh, I didn't change it to min. Yeah, and you get -1 after squaring it. So that would be 1, 9, 4, 9, 12, 1. Yeah, and this would be 1. So -1 would be the smaller of the number after squaring it. Yeah. Again, I don't do a lot of math like this, so it's cool, but I'm not overly excited about it because I don't see myself using it a lot. I know this is getting a little long, but we've got mean and median, and these are two simple ones. And the see also median, which is here, and see also mean, which is here. So let's just knock these out real quick. All right, so r dot mean is average. It takes a list of numbers and gives you a number back. It returns the mean of the given list of numbers, right? So the average. So the average of x's, 2.4, blah, 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 that long number, you know? Um, you can't partially apply it because it only takes one argument. So that's pretty useful. Um, I'm gonna take a detour and go to converge, one of my favorite functions in Ramda. Look at that type signature. Um, but they have an example of average. I remember when we looked at it because I was like, yeah, that's cool. Oh, I can't do that. Here, this on a separate line. So converge, just a real quick recap. What it's doing is it's taking the x's and first it's going to sum the x's and then get the length. And that's how we calculate an average. We add all the numbers together, we divide it by the amount of numbers, and that gives us the average. Or yeah. So first so basically we're passing in the arguments and then we're calculating the arguments that are going to be used by divide. So divide needs the sum of the numbers and the length of the numbers, and we divide the sum by the length, and then we should get the same result. We do. So, that's cool. But if you want to get the average, this is much easier, right? And then it shows here if you pass an empty array, you get not a number because it specifically says you need an array of numbers, not an array of nothing or a number. And of course, if you use letters or something like that, I don't know, it would crash or it would, you know, give you not a number. And then not the opposite, but the one that's related is the median, has the exact same type signature, an array of numbers, returns a number. It returns the median of the given list of numbers. So this is the number in the middle. If you sort the numbers, ascending or descending, it's going to give you the middle number if it's odd. So we have 1, 2, 3, 4, 5, 6, 7. So we have odd numbers here, and we get 1. So if I just order this in my head, we'd have -1, 1, no, sorry, -2, 1, 1. I gotta write it down. -2, -1, 1, and 1, because there's 1 and 1 here. Then 3 and 3. This is 3 and 3. and then 12. Be seven numbers. One, two, three, four, five, six, seven. Yeah. So the fourth one would be the middle number, which would be one, and that's what we get. And then if you have an even amount of numbers, what it's going to do is say one, two, three, four, five, six, seven, eight. So the middle number would be right here in between the one and three. So we're going to add the one and three together, and that's going to give us four. Then we divide by two. That'll give us two, and that's what we get here. So it just depends. The median is always the middle number or the average of the two middle numbers if it's even. And that's all there is to that. So yeah, that's a whole bunch of math functions that just happen to be in order in the M's. The next one is memoize with, which is pretty cool. We'll look at it. And then we have like a ton of merge functions. One, two, three, four, five, six, seven, eight, nine. Wow. And then we've already looked at min and min by. So we'll do another video. We'll knock out the memoize. Maybe I'll do that on a separate video, even though it might be kind of short. And then we'll group these merge functions together, at least some of them. So anyway, thank you for spending your time with me. Tell a friend, and then I'll see you in the next video.